3 and 4.
What's it called? If it's what is it? It's will it be the same if it was a 2 by 1 and a 1 by 2?
Okay, so you have to think that through for a second. Alright, you go, if you had a 2 by 1 and you tried to multiply it by 2 by 2, what happens?
No,
Fails.
wait, is it identical,
I think.
Is it?
of a 2
again?
boy, is it identical 2 by 1? So it'll just be 1 0 1. 1 0 1. For like, oh wait, no, a 1 0.
Oh, is that an identity matrix? Is that what you're asking? Short answer, no. Identity matrices are always square matrices.
Okay.
So in other words, they have to have the same downers across. Cool, okay, so we get that, great. If these were back in normal algebra again, what is this I effectively multiplying? 1, right? So for you guys, number 1 is an identity. You just don't really think about it because whenever we do times by 1, you just go, well, drop the 1, it doesn't do anything. Same thing with this, times by an identity, you can drop it, it doesn't do anything. So long as it's operating on square, isn't it?
So long as it's operating on what?
On square matrices.
Okay. So if it was a rectangular.
If it's rectangular, now I have to think.
What is the most used number?
1 is the most used number. 0 is the least used. Just if you go through all the numbers anyway. Yeah, anyway, doesn't matter.
I feel like it's 5.
That's fine, that's fine. Okay, cool. Alright.
I feel like it's 5.
16, 15,
What we need.
14, 13, 12, 11.
So A multiplied by its inverse would have to equal the identity. Right?
Why is that?
Think about what the inverse is supposed to do. Right? We wanted to undo something. It's all so if you wanted to divide by half, the inverse of that is times by 2. Right? So if you have 2 times a half, what happens?
Becomes 4.
2 times a half.
I mean, it becomes 1.
1. Right? The identity.
1.
Right? So if you multiply something by its inverse, you should always get back to 1. Right? 27 on 2, right? Its inverse is 2 on 27. You multiply them,
1.
you get back to 1. Yeah? So that's what we're going to exploit.
So half times by 2.
Yes.
Ah.
It's just 2 divided by 2.
So therefore, in pseudo, anyway, divide by A is kind of equivalent to multiplying by A inverse.
I mean, it makes sense.
Yeah? Okay.
Would it not be like absolutely identical though?
So
Would it not be like absolutely identical, pretty much?
absolutely identical.
Like if I subbed in divide by A by multiply by A inverse.
Yeah, I'm going to be a bit fast and loose with these rules because it'll be true for the next 2 years and then it depends on what you like with it.
Sweet as.
For most of you it'll be true forever, but yeah, that's definitely not, it's definitely not bulletproof. Anyway, cool. So, of course, the way we're going to do this is not, and I'm just going to tell you.
I don't think you're allowed to shut that door. Okay, so if that was our original matrix A, Yes.
right, then the inverse of matrix A is this.
Well, what?
Yeah, well, what? Now you can generate this yourself, but it'll take you too long, so I'm just giving it to you instead.
Why?
Okay.
Why is this?
Why is this?
Yes.
I'll leave it to you as an exercise to the reader. If you do this matrix, multiply by that, and then divide everything by this, right, you'll end up back at 1, 0, 0, 1.
Oh, no, I'm good.
Yeah, exactly. Right. So I'll just leave that for you guys. So let's try to figure out B inverse for way back there.
Like the B that we used?
The B that we actually used back
Okay, would it just be
1.
8.
Over. What's in position A?
8.
No, it's not.
5.
Oh wait, sorry.
5.
Oh, sorry, I thought you meant like we're
What's
drawing
in
it now.
position D?
No, I was trying to draw it. Dude.
Oh my
Position B.
6.
Position C.
7.
Multiply by. position, sorry, now, D now moves into this position.
So it's 8.
That's
That's what I was trying to do, teacher.
So would that just be negative?
No, negative 6, negative
Okay,
7, and 5.
Go.
Bet you didn't have that one, did you, genius?
What do we got? 40 minus 42, is that
We're at
right?
war.
Yeah?
What's that? 40 minus 42.
Yeah,
Negative 2. Yeah, that's it. Oh my god, it's a half. Negative half, really.
Yeah, went from being easy to a lot.
Yeah, exactly.
So that means it's negative 4, positive 3. Oh god. Lovely. So, wait, what did we just solve for? B, like the B, inverse of B?
Inverse of B.
Alright.
What did we just do?
Now, how confident are we that we've done that correctly?
I hate this.
No, not at all.
So, how could we check?
I don't
Oh,
know. Ask Mr. Joy.
You could just. Nah, I was always in my own.
Times
Right, times this by the original or the original by this.
Oh.
Why?
Because it will equal 1. They should equal 1.
It should equal
One
identity.
should equal
in
identity.
matrix identity, right? Okay, so
Identity.
It works.
let's try that. Now we could go, oh, by the way, works the other way around as well.
Oh, do you have Messenger?
Cool, let's try
I just.
B inverse multiplied by B.
Did we tell you?
So B inverse,
You know the short thing.
we have here, negative 4, 3, 7 on 2,
Do you want
negative 5 on 2. B, we had, what was B? Was it 5, 6, 7, 8?
5, 6, 7, 9. I'm 8.
Can make this a bit bigger.
Yeah, and I'm the doubles.
I just excluded A from my answer. Because that wrongful doing is yours.
Go. Okay. This position, what am I going to get?
Negative 20. Positive 21. Negative 24. Positive 24.
0.
Oh, damn. 0. It's just going to be 0.
Yeah, but you need to verify that it's going to be 0.
35 on 2.
Minus 34 and 2.
35 on 2.
Do the actual math.
42 on 2.
Minus
Minus 40
41
on 2. Minus 40 on 2.
Good try.
Isn't it 41 on 2?
So
Well, it's
close.
8 times 7. Sorry, 8 times 5.
41, apparently.
No,
According from our reliable sources.
So we're pretty happy.
I'm not happy at all.
You're not happy at all? Okay.
You're not, I don't blame you.
Whoa, 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 whoa,
Yeah,
whoa.
worried. I'm worried.
What happens if there's, was it B inverse of B or is it just B to the power of negative 1?
1 0 0 0 0
B, so B to the power of negative 1 in matrix means the inverse.
Okay, so the inverse of B
Yeah.
divided by A.
The inverse of B divided by A isn't defined properly in matrix, but you mean the inverse of B multiplied by the inverse of A?
That's it.
Yeah,
Oh,
it'll
that
be
can,
some-
because that, oh, that's easy.
It'll work because they're both 2 by 2 matrices. You'll get a 2 by 2 result, but it'll just be some set of numbers, some garbage.
But will it not have any
How would
correlation
you do-
between A
how
and
would
B?
you do A divided by
It'll have
B?
correlation between A and B, but it won't be like neat and obvious or anything.
How would you do A divided by B if you weren't allowed to use
You
inverses?
don't.
You don't.
It's a short answer. Division is not well defined for matrices.
Okay.
So just multiplied by the
As well as
inverse.
the fraction.
Yeah, multiplying by inverses, that works just fine.
Sweet.
It has the hamstring of you need to actually have an inverse because it is possible to not have them.
I feel like that makes sense.
Yeah. Also, both of these need to be true in order for it to be in inverse. Otherwise, because you can get things that are like A times B equals the identity, but B times A does not equal the identity, in which case they're not inverses.
But A
It has
times
to be
B.
true both ways. So
A,
A multiplied by some matrix might equal the identity, but if the reverse is not also true, then they aren't inverses. So you can have what looks like an inverse, but you've got to test it both ways to make sure that it is an actual inverse. Yep.
What if the
Shouldn't
The
that
formula there is 1 over AD minus BC, right? What if it wasn't a 2 by 2?
What if it was?
What if it wasn't a 2 by 2?
It wasn't a 2 by 2.
What if it was
Okay.
just I?
That's a great question. I can write out the thing for you for a 3 by 3 if you really want,
What about?
but you won't touch it.
What if it was just 1 by 1?
Oh, inverse of a 1 by 1 is like a bit trivial. So, yeah, put it in purple, special case. You've got some value of this, right? You need to multiply it by something to equal this.
Multiply.
With the inverse of
Done.
Yeah, okay. Oh, so that's easy.
Yeah, trivial.
So it wasn't trivial.
Trivial.
The process wasn't. It's easy as.
Yeah, that's okay. That's what trivial means.
No. And see,
Trivial.
was that so trivial of you? No, that didn't work out either. Was that so trivial explaining that? No.
No.
Exactly.
Because it went
Because
down
I'll tell you what,
weird
I know what it means.
Anyway, cool. So that's that. That's good.
Dude, I thought it meant annoying. like annoying to do, like a waste of time.
To be honest, that's exactly.
Oh, that's exactly what it means. Like easy, like a waste of time. Oh, well, I had it. Dude, why you gotta do me like
Because
that?
you can't get coronavirus.
Oh, wait.
I like my spot better.
Matter of fact.
Cool. This thing, this denominator here, it's called the determinant,
The debt.
right? Shortened to det. So the determinant of matrix A is this.
I'm in a lot of debt.
What about B? Is like the determinant of
The
B?
determinant of B is whatever its numbers are. Yeah.
But like in algebra form, like. It's like
Same
AD.
thing, just so long as matrix B is a 2 by 2, it's the same positions.
Okay.
Moved across. Now, we said it was possible for things to not have a determinant. It was possible for things to not have an inverse.
Yes, you did say this.
Right. Can you spot under what conditions that would be true?
Or if there's a 0 in there,
A what?
or a 1,
A what?
or like a 7.
A what? What was your question?
Zero was a good start, and then you wandered off.
What was your question?
Yeah, I'll stick with 0
Under
then.
what conditions will the inverse not exist?
Undefined.
Okay,
0.
what makes things undefined?
Negative
When you
numbers.
divide it by 0.
When you divide by 0, so when...
Oh, when D, A, B or C equals 0. No, when A, D minus B, C equals 0.
Alright, so when the determinant equals 0.
Yeah.
Right. If det A equals 0, no inverse.
What was if there's no inverse? Then does that mean that the
Well,
answer
then
is
you are out of luck if you wanted one.
Then there's no identity.
No. Identities are totally separate idea. These are always identities.
Done.
Okay?
Yes.
Inverses may or may not exist.
Can anything become an identity? What?
If you have its inverse.
So
right?
if A doesn't have an inverse, can it still become? Is there another way to like?
Yeah, there is. There's other caveats on that now. Okay. So if it's a square matrix, you can always manipulate it to become an inverse. Oh jeez. If it's a square matrix, you can always manipulate it to make it an identity. However, that's not necessarily helpful because you can plus and minus things to it, which doesn't necessarily mean anything. Right? But not every matrix, even if it is a square matrix, not every matrix will have an inverse. Because it's possible for this to equal 0, in which case you have no inverse. And we're going to exploit that later on.
What's x divided by x?
1. Anything by base.
So long as x is not 0.
Or infinity.
Well, then it's not a number.
Haha.
And
So
if
how
it's
would
just
you-
approaching infinity, then you can run L'Hopital's law and then potentially resolve that. So if you have x, something like x squared divided by x, right? If I make x approaching infinity, it looks like I've got infinity divided by infinity, yeah? Right, which is saying it's not defined or whatever, yeah? But if you think about it for a second, x squared divided by x, you can simplify that to just x, in which case it goes off to infinity. Yeah? And you can have the same, you can have the reverse, so you can have x over x squared, seems to be infinity divided by infinity, but if you use look at where they're going, you simplify it then, you get 1 over x, right? So it's x
Wait,
approaches
wait. So
that
infinity over
approaches
infinity
0.
does not equal 1.
Sorry,
Infinity over infinity does not equal 1.
not necessarily.
Wait,
Equal
right.
anything,
Alright, so 1 over
including
1,
undefined.
1 divided by like approaching infinity is 0.
It
Did
approaches.
you just say?
1 divided by x, where x approaches infinity, that result will approach 0.
Oh,
So the limit.
that makes sense, yeah.
Yeah, we're going to do limits in the not too distant future.
Oh, come on.
So
Why would you do
we'll
that?
deal with exactly those sorts of questions.
Oh.
And then we get to do calculus after that because we have limits to describe.
What's
ideas.
calculus?
The study of change in a very loose way. Study of rates of change.
So it's nature.
Change in general. Well, yeah, it's like putting
Wait, is it
math
actually?
to infinitesimal changes.
Huh.
Anyway,
Give like an example
of what?
of like something in calculus.
Okay, y equals mx plus c, what's the gradient?
M.
Okay, y equals x squared, what's the gradient?
1.
Yeah, 1. Oh no, it's an M.
What is the
It's a
gradient?
non-linear. Non-linear.
Right, it's non-linear, right? So does it have a defined gradient?
No.
No, but it does have a rate of change.
Yes, it would have to.
Okay, well the rate of change is 2x.
Why is that?
Yeah, well, you said you just asked for an example. You didn't ask for a
I didn't ask for anything.
Oh, TJ. You asked for an example.
just said
I'm
Except for
saying
the,
no,
yeah,
what
except,
about
yeah,
the start
okay,
first?
fair enough, fair enough.
I'll let start first. Cool, so that's that. Beautiful. See, that's everything.
And if I didn't say it, good afternoon, good morning, and good night.
You know what, TJ? No one cares.
Take that.
Do you know where that's from?
No.
Yeah, this guy knows. Just said Trim and Chew. I was like,
Yeah, the Truman Show.
the Truman Show.
Because you've
Yep,
been the
that's
best at listening.
So,
This guy's giving a fuck.
That's what I'm saying.
so 70 is most of
Well,
it.
instead of not giving a fuck.
70 ends with matrix multiplication. 7F deals with inverses and inverse matrices. Sorry, identity and inverse matrices.